Hi there, my name is Miss Townsend and I love math. Welcome to Math with Townsend. This video is for grade 11 students in functions and relations working on the summative package. This is question number 11. It says a new drug persists in the human body following the model, and here they give me an equation. And it says in this model, M is the mass of the drug remaining, MO is the mass of the dose taken, and T is time in hours since the dose was taken. A patient takes a 200 milligram dose. And I need to answer some questions, how much of the drug remains after 1 hour, and determine when there will be half of the drug remaining. So when I look at this equation, I can tell that it's an exponential function because the independent variable, t, is in the exponent. So the first thing I need to do is I need to rewrite this equation using the information I'm given that the original dose is 200. So the mass that remains is 200 times 0.55 and then over t to the 2. So again, what I can tell just by looking at this equation is that it is a decay model because only 55% of the original dosage will remain after every time period. And I can tell that the time period is 2 hours. So I'm told that t is time in hours, and this number here tells me that every 2 hours is the time period for this 55% reduction. So the first question is really straightforward. All it says is how much of the drug remains after an hour. So I just need to let t equal 1 and do my calculations. So after 1 hour, this is the math I need to do. So in my calculator, I'll do 0.55 to the exponent half, which of course means I'm just taking the square root. So I get 0.7416, multiply that by 200, and I find that 148.3 grams are remaining after an hour. And I just like to logically make sure that that's true. We know that 2 hours, there would be 55% remaining, and 55% of 200 is about 110. So the fact that I have more than 110, because it's only been 1 hour, so I think I'm pretty confident in my answer. So let's look at the next part of the question. It says determine when there will be half of the drug remaining. So again, let me set up the equation using the 200 value, even though I don't really need to, and you'll see why in a second. So this question is asking me to find t. So what is the time that's required to reduce my starting dose to half? So because I've put 200, what I want is to end up with 100. And again, I'll show you in a minute why it doesn't matter if I put 200 there or not. Because the first thing I need to do to solve for this exponent is I need to divide both sides by 200. And when I divide this by 200, I get 0.5. So in reality, it doesn't matter how much I start with. If I want only half to remain, I know that the remaining amount should be 0.5 because that represents 50%. So now comes the issue where I have an unknown value in the exponent. So this t is in the exponent. So here's my approach. So the first thing I'm going to do is I'm going to get a different variable in the exponent. So I'm just going to focus on finding, oops, I'm going to focus on finding what exponent works, and then I'll worry about actually solving for t. So I'm going to rewrite this as just a simple exponent x. So now I need to solve for x. So how do we solve for x if x isn't an exponent? Well, there's two methods, and I'm not sure which method you may have done with your teacher, so I'll talk about both. One method is basically guess and check. So I'm going to guess values of x, and I'm going to see what 0.55 to the x would give me. And again, my goal is to get as close as I can to 0.5. So for example, because I'm reducing inside, well, let's just guess x equals 2 and see what happens. So 0.55 to the exponent 2 gives me 0.3. So that's too much, right? Like that is too much of this mass, sorry, too much of the original mass has been reduced because I only have 30% left. So let's try 1.5. So in other words, I want to give it less time to sit around and decay. So to the exponent 1.5, that gives me 0.4079. And again, that's too much time, so let's reduce the amount of time I let my drug decay. So exponent 1.3, I get 0.46, so that's still too much time. Let's try 1.2. So the key to guess and check is that you just have to show the progression of your guessing and checking. Guess and check is not something you can just do in your calculator and then say, see, I magically found the answer. You have to make sure that the guess and check is, um, the logic is shown to your teacher. So I'm pretty close. So I'm going to get, um, you know, I'm going to try to get close to that number. I'm still a little bit too much time has passed because I don't quite have enough material left over. So I'm going to try 1.18. Ooh, I'm getting there. I got 0.493. And at some point I'm going to say close enough, but I like to see what I can do. Let's try 1.17. 0.496. Ooh, I'm pretty darn close. Let's see what I have. This is what I have. So that would pretty much round me to zero point 0.5. So I would say in 1.17 hours, or what would that be? That would be an hour and about 10 minutes. I would have half of my original dosage remaining. So that's one option. And when I looked in your textbook for functions and relations, I saw that this is an option that they demonstrated. But, why don't I show you the other option? Um, Now, here's why you might not have seen this option. This option involves something that you haven't learned yet. And so I'm going to kind of, oh, hold on, Miss Townsend. I'm not done over here. Phew. I wasn't solving for t here, was I? I was solving for x. So I don't know what t is yet. Boy, oh boy, it's a good thing I caught that. I know that x is 1.17, not t. But I know that x was what I substituted for t over 2. So now I can solve for t, multiply both sides by 2. I get that t is 2.34. Whew, boy, oh boy. If I knew how to edit idiot videos, I would fix that, but I don't really know. 2 hours and, so what's 0.34 of an hour times 60? 2 hours and 20 minutes. All right, that's better. Okay, so in about 2 hours and 20 minutes, I will have half of my original dosage left. And that makes sense. Again, if we just look back at the formula, we knew that the original formula was a 2-hour time frame to get to 55%. So slightly more than 2 hours, we would expect to be slightly less. Okay, so that was the guess and check method. But let's talk about the other method. And again, um, the problem with this method is that it's a calculation that isn't going to make sense to you until you take grade 12 math. But you all have scientific calculators, so I'll show you what to do. There is a button on your calculator called log. Log is short for the word logarithm, which involves the inverse operation of exponents. Now, again, don't worry about that. Worry about this. If I want to find the answer directly to an unknown exponent, which is what I'm doing here, I can set up my log like this. Now you have to be careful to set it up properly. If I have a equals b to the x, then x would be log a over log b. The way I remember it is this number here is the base, right? Because an exponent is on a base. And so the base goes on the bottom. So it sort of just makes sense to me. B for base and bottom. So if I just simply take my calculator and type log, oh, where's my log button? Log 0.5 divided by log 0.55, I get an answer directly, and it tells me that x equals 1.16, which means that so t over 2 is 1.16, so t is equal to 2.32 hours. So just be careful with this method. If you've seen it in class, great. You know you can use it. If you haven't seen it in class, just check with your teacher. Make sure that they're comfortable with you using this method, because they might want to see the guess and check process, um, which is just as mathematical. It just, it takes that little bit more time. Okay. And I think I'm done the question, right? Yay. Okay. So thanks for watching. See you in the next video.